Welcome to Kaggle's journey through time. I'm thrilled to share my insights for the inaugural Kaggle Hackathon, specifically focusing on the trends over time track. Alright everyone, let's kick things off with Phase 1, Introduction to Kaggle and Why It Matters. Before we dive into Kaggle itself, let's briefly look at AI's incredible journey, especially the rapid leaps we've seen since 2015. Think about it. Deep learning revolutionized image and language processing, AlphaGo showed AI mastering complex games, and then came the explosion of generative AI, with tools like ChatGPT making AI accessible to millions. We're seeing AI now transform everything from self-driving cars to healthcare diagnostics. My reason for highlighting these recent AI advancements is simple: Kaggle isn't just a platform, it's AI's living laboratory. It's a dynamic ecosystem that both mirrors and actively drives these very innovations. By understanding where AI has been, particularly in this last decade, we can truly appreciate how Kaggle fosters this innovation and serves as a central hub for the global AI community, pushing the boundaries of what's possible. It's truly where the future of AI is being built. Analysis reveals a fascinating shift on Kaggle: the rise of specialized AI (ML) niches. Tags like Hugging Face, Object Detection, and Data Storytelling show explosive growth, some increasing by hundreds or even thousands of %. This clearly indicates the community's strong interest in advanced, targeted tools and very specific AI subfields. Users aren't just doing general data science anymore, they're diving deep into cutting-edge methods and domain-specific applications, showcasing a move towards more refined and powerful techniques in their work. This push into specialized areas is reshaping the entire platform. While foundational tags like exploratory data analysis and data visualization are still crucial, their explicit usage has declined. This suggests that core data science practices are now often integrated into broader, more complex pipelines or are simply becoming implicit steps within advanced solutions. The community's focus is clearly shifting towards the outcomes of these advanced techniques and the high-level problems they solve, rather than meticulously tagging every foundational step. It highlights a maturing ecosystem where underlying skills are assumed. We also see a significant shift in how users engage with learning. Surprisingly, tags like beginner and learn are seeing a notable decline. This doesn't necessarily mean fewer new users, but perhaps a change in how they learn or share. It could be that new users are quickly progressing beyond the beginner phase, or they're relying on external learning resources before coming to Kaggle for application. A key factor might also be the rise of private notebooks. Users might be keeping their initial learning and exploratory work private, only sharing more polished, advanced content publicly. This suggests Kaggle's public kernel space is evolving from a primary learning hub for basic concepts to a more focused environment for advanced applications, competition solutions, and sophisticated research. The dramatic surge in GPU usage fundamentally stems from the rise of deep learning and large models. Advances in these areas demand massive computational power. Consequently, more complex problems are being tackled on Kaggle, and performance-oriented solutions are coming to the forefront. This clearly demonstrates the platform's technological progression. The increasing number of forks per kernel on Kaggle is a powerful signal. Our graph shows a clear rise, indicating kernels are becoming more reusable and foundational for new projects. This means the community is actively building upon shared work, accelerating collective learning and innovation. It truly highlights Kaggle's evolution as a dynamic hub for collaborative development. The average number of forks per kernel has, interestingly, decreased over time, as our graph shows. This suggests a shift. Perhaps kernels are becoming more specialized, serving niche needs, or users are creating more complete, standalone notebooks. It could also mean more content exists, making it harder for individual kernels to stand out for direct forking, or users might be learning and extracting code without full forks. Alright, let's look at the most interacted with kernels on Kaggle, and what they tell us about the community's evolving focus. Our graphs clearly show the enduring strength of tabular data. Even with all the new advancements, high-quality solutions for structured data problems consistently gain significant upvotes. However, we're seeing a proportional shift away from pandas in these top kernels. This indicates users are increasingly adopting more specialized or performance-oriented tools, perhaps like polars, Dask, or even direct NumPy, PyTorch operations, for large or complex datasets. Finally, there's a definite growing interest in advanced techniques. The rise in deep learning and classification in top kernels confirms the community's keenness for sophisticated AI methods. This all points to Kaggle being a hub where advanced, efficient solutions are truly celebrated. The median dataset version size on Kaggle has notably decreased over time. This suggests a few things. Perhaps datasets are becoming more focused and specialized, or creators are using better compression techniques. We might also be seeing an increase in synthetic data or greater reliance on external cloud storage for truly massive files, meaning less raw data needs to be directly hosted on Kaggle. Let's look at the evolution of dataset types on Kaggle. Our analysis shows image, vision datasets are now ascendant, claiming the top spot in 2025 due to continuous advancements. While tabular data saw a peak and then a slight decline, it remains fundamental. Text, NLP datasets hold strong and stable proportions, driven by large language models. This clearly signals Kaggle's shifting emphasis towards visual AI solutions, mirroring broader trends in the field. When we look at industry-specific trends on Kaggle, our data table reveals significant limitations. The broad industry tags are not consistently applied, meaning most competitions aren't categorized this way. This results in sparse and volatile data, making it incredibly difficult to draw reliable general conclusions about overall industry focus. For example, a 1.00 sports ratio might just mean only a few competitions were tagged that year, and they all happen to be in sports, not a broader shift. Essentially, this specific tagging doesn't give us a clear picture of Kaggle's industry landscape. Our report paints a picture of a maturing and dynamic platform. We've seen kernel content specializing, with GPU dominance and advanced techniques like hugging face and object detection skyrocketing. While foundational data science steps are less explicitly tagged, they're now often integrated. Datasets are getting smaller and more specialized, with image, vision data taking the lead by 2025. User engagement is evolving, with skill-level tags declining, suggesting Kaggle is becoming more of a hub for applying advanced skills and competition than just basic learning. We also see growing collaboration through total forks. Ultimately, Kaggle is not just reflecting AI trends, it's driving innovation. It's solidifying its role as a premier destination for advanced AI, ML applications, fostering practical expertise, and will continue to be vital for tackling the complex, real-world challenges of tomorrow's AI landscape. I'm thrilled to share my insights for the inaugural Kaggle Hackathon. This meta challenge invites us to explore Kaggle's own data to understand 15 years of AI and machine learning progress. Inspired by Kaggle Competitions being a gold standard for AI evaluation, my project, using the Meta-Kaggle and Meta-Kaggle code datasets, maps out this unique ecosystem's evolution. My analysis unfolds in distinct phases. In Phase 2, diving deeper into Kaggle trends, I meticulously tracked the evolution of AI, ML trends. I first pulled unique kernel tag names from the df_kernel_ data to understand Kaggler's vocabulary. Then, by strategically grouping these tags, from broad concepts to specific solution approaches like deep learning, XGBoost, and transformers, I visualized their rise and fall over time. Moving to Phase 3, diving deeper into user roles and contributions, the focus shifts to the human element. We explored how Kaggle's community dynamics are changing. I analyzed aspects like novice user engagement, the evolution of collaboration through kernel forking, and the characteristics of highly upvoted content. This revealed Kaggle's transformation into a platform for continuous learning and robust collaboration, where beginners truly thrive. In Phase 4, unveiling trends in the Kaggle ecosystem, I broadened the scope. I examined the evolution of dataset sizes and types, like image, tabular, and text, and identified emerging industry applications within competitions. This provides a comprehensive picture of the platform's growth and specialization in real-world problem-solving. Let me quickly show you how I brought this data to life. I began by loading essential Meta-Kaggle datasets like kernels, tags, competitions, and datasets. As you can see here in my Kaggle notebook, I performed crucial steps like data cleaning, type conversions, and intelligent merging of tables to create the foundation for my analysis. Then, I leveraged libraries like Plotly Express to generate the interactive visualizations you see in my report, allowing me to uncover these key trends. These insights paint a comprehensive picture of Kaggle's journey as a bellwether and catalyst in AI. If you're curious about the detailed methodology, code, or to explore the interactive plots yourself, I invite you to check out my Kaggle notebook in the full write-up, link below. Thank you.